Good morning, children. Welcome to another session of Physical Science online classes, 9th class physics. In the previous class, we have learnt about uniform motion and non-uniform motion. So, what is uniform motion? What we have learnt? So, the body is said to be in the uniform motion when its velocity is a constant. That means when the velocity of an object does not change, it remains constant, then the body is said to be in the uniform motion. Then the opposite will be the non-uniform motion. That means a body is said to be in the non-uniform motion when its velocity changes continuously. When the velocity of an object changes, it is said to be in the non-uniform motion. Then what is velocity and how it changes? Here, already in the previous classes, we learned that velocity is nothing but the speed with the direction of an object is known as velocity. Velocity includes two factors here, speed and direction. Okay, so the velocity of an object can change in three ways. Okay, the first one is the velocity of an object can change in three ways. First case, the speed of an object changes, speed changes with the direction remains constant. With the direction remains constant. When the speed of an object changes with the direction remains constant, that is one case. And when direction changes and speed constant, speed remains constant. The second case is when the direction of an object changes, the direction of motion of an object changes, but the speed of the object remains constant. And third one is both speed and direction changes. Both speed and direction changes. In either of these three cases, the body is said to be acquiring some change in velocity. Okay, velocity is nothing but, what is velocity? Velocity is the body contains velocity. So, speed with direction is called velocity. Speed with indicating direction is called velocity. So, when speed of the object changes with the direction remaining constant, the body is having some velocity. When the direction of the motion of the object changes, but speed remains constant, in that case also the body is said to be having some velocity. Or the both things here, speed and direction of the object, both of them changes simultaneously. In that case also we can say that the body is having some velocity. Okay, velocity is changing. The change in velocity is taking place. So the change in velocity takes place in the three ways. In these three ways, the change in velocity takes place. So when the velocity changes, here we have to notice one important thing, that when the velocity of an object changes, the body is said to be accelerated. The body acquires some acceleration. Okay, what is acceleration? Here the term acceleration indicates there is a change in velocity. The body has some change in velocity. In that case, the body is said to be accelerated. And this acceleration gives the idea how quickly the velocity of an object is changing. Acceleration, what it gives? Acceleration gives an idea about how quickly the velocity of an object is changing. Here acceleration means, I don't mean that there is only always there is a object is moving with high speed. We cannot say like that, because here acceleration indicates the two things here. Acceleration may be the body is said to be accelerated when its velocity is changing. Changing means the velocity may be increasing or decreasing. In both the cases, we can say that the body is said to be accelerated. So when the velocity is increasing, we can say it has acceleration. Okay, and when the velocity of a body is decreasing, in that case also we can say that the body has some acceleration, but it is a negative acceleration. So the negative acceleration will be called as the retardation. Okay, when the body is increasing its velocity gradually with time, then it is said to be accelerated. But when the body is decreasing its velocity gradually with the time, in that case the body has some negative acceleration. This negative acceleration is known as the retardation. Okay, then this is about the acceleration. So in our daily life also, we'll be observing, we will experience the acceleration in our day-to-day life also when we are traveling in a bus or car. Okay, in two cases we feel the acceleration, that is when the driver press accelerator or when the driver press brakes. In the two cases, when the driver press accelerator, the speed of the car increases. when the driver press brakes, then the speed of the car decreases. In both the times, we can feel the acceleration. In the first case, the vehicle speed increases when he press the accelerator, when the speed of the vehicle increases. In the second case, when the driver press the brakes, then the speed of the vehicle decreases and comes to rest. Okay, so in both the cases, we will feel some acceleration. Okay, positive acceleration and negative acceleration. Okay, so we will see in acceleration and its types of acceleration. Okay, we have uniform acceleration and non-uniform acceleration. Uniform acceleration. Now we will see what is uniform acceleration. Okay, here this is the definition of uniform acceleration. A body has a uniform acceleration if it travels in a straight line and its velocity increases. Okay, velocity increases by equal amounts in equal intervals of time. Okay, body has a uniform acceleration. When the body has said to be having uniform acceleration, it is said to be having some uniform acceleration if it travels in a straight line. See here, you can observe this example. In this example, the car is traveling in a straight line path. Okay, and its velocity increases by equal amounts. Velocity increases by equal amounts in equal intervals of time. So this car is traveling from point A to point D. First, from point A to point B, B to C and C to D. Like this we have divided. And from A to B, the time intervals, we have taken some equal intervals of time. See here, 5 seconds. A to B, it has taken 5 seconds time. And from B to C again, it has taken 5 seconds time. C to D also, it has taken 5 seconds time. So in the equal intervals of time, okay, how the velocity is increasing. You see, from point A to point B, what is the initial velocity? Here when we are talking about the velocity, change in velocity when the car is moving from point A to point B. Okay, here at point A, the velocity of the car is said to be the initial velocity, and velocity of the car at point B is said to be the final velocity. Okay, this is initial velocity and this is final velocity when we are talking about the traveling of the car in between these 2 points from A to B. Okay, so at point A, the car is traveling with 10 meter per second velocity. This is said to be the initial velocity. Okay, u is equal to 10 meter per second. Initial velocity. And at point B, the car is traveling with a velocity of 20 meter per second. This 20 meter per second is said to be the final velocity, and you all know that final velocity is represented with u, and final velocity is represented with v. Okay, v is equal to 20 meter per second. U is the initial velocity, it is 10 meter per second, and v is the final velocity, it is 20 meter per second. Okay, now how can we calculate the acceleration in these 2 points? See here, acceleration is the ratio of change in velocity with time. Ratio of change in velocity with time. So the formula of acceleration is equal to, acceleration is represented with a letter small a. Okay, a is equal to change in velocity, means the final velocity minus initial velocity, that is v minus u, by t. It is the ratio of change in velocity with the time, is called acceleration. This is the formula of acceleration. A is equal to v minus u by t. Here v is the final velocity, u is the initial velocity, and t is the time. Okay, from A to B, from point A to point B, what is the acceleration? Here we can calculate the acceleration when the car is traveling from point A to point B by using this formula. Okay, A is equal to v minus u by t. A is equal to, v is the final velocity, means at point B, final velocity is taken as 20 meter per second, minus, and u is the initial velocity, that is 10 meter per second, by time t is the within 5 seconds. Within 5 seconds, the time interval is 5 seconds. In 5 seconds, its velocity has changed from 10 meter per second to 20 meter per second. Its velocity increased by 10 meter per second. Okay, here within time 5 seconds. So 5 seconds is the time interval. And now 20 meter per second minus 10 meter per second, that is equal to 10 meter per second divided by time 5 seconds. So 10 by 5, that is equal to 2. And meter per, what about the units here? See, meter per second. Hence we have to write meter per second square. Meter per second square is the units for acceleration. What are the SI units of acceleration? Here means the units of acceleration is equal to meter per second square. How many meter per second square? That is 2 meter per second square. This is the acceleration. There is an increase in the velocity. C, and here from B to C also again we can calculate the acceleration. Here to here also that there is a change in velocity. Velocity is increasing. From B, it is when it is traveling from B to C, at point B, the velocity of a car is 20 meter per second, and at point C, the final velocity is 30 meter per second. Now, again we are going to calculate from point B to point C, what is the acceleration of the car. If you want to calculate from point B to C, the acceleration A is equal to V minus U by T. Again, we are going to use the same formula. So, V here is the final velocity, that is C here. So, at C, it is traveling with 30 meter per second, minus U is the initial velocity, that is because we are considering it the traveling of car from B to C. So, here B will be the initial velocity, that is 20 meter per second. And again, the equal intervals of time. Here again, it is taking 5 seconds time. So, it is 5 seconds. 30 minus 20, that is 10 meter per second by 5 seconds. Again 10 by 5, that is equal to 2 meter per second square. Remains the same here. The change in velocity remains the same. Here to here there is a increase in the velocity by 10 meter per second. Here to here also there is an increase in velocity by 10 meter per second. And here to here 30 to 40. That means again the increase in velocity is 10 meter per second. From point C to point D also we can calculate, that is final velocity 40 meter per second by initial velocity 30 meter per second divided by 5 seconds. Again in 5 seconds. 40 minus 30, that is equal to 10 by 5, that is 2 meter per second square. So in equal intervals of time, the car is traveling with the equal change in velocity. In each 5 seconds time, in every 5 seconds time, the car is increasing its velocity by 10 meter per second. The change in velocity in equal intervals of time remains the same. See here, velocity increases by equal amounts. Here to here 10 meter per second, here to here again 10 meter per second, here to here again 10 meter per second. Like this, gradually there is a increase in the velocity in equal amounts. The velocity is increasing in equal amounts in equal intervals of time. In every 5 seconds time, there is a gradually increase in the velocity. Equal intervals of time. The velocity of a body is increasing in the equal amounts. In that case, the body is said to be in the uniform accelerated motion. This is about uniform acceleration. In this video, we will see some examples for uniform acceleration. Okay, what is uniform acceleration? When a body has a uniform acceleration when it travels in a straight line and its velocity increases by equal amounts in equal intervals of time. This is said to be uniform acceleration. A car traveling on a straight line is the example for body having uniform acceleration, and other examples are like a body which is freely falling object from certain height. Suppose when we drop a ball from certain height, then it reaches the ground, and in this path when it is falling from certain height to the ground, its speed gradually increases. And it is so it increases in equal amounts. Hence we can say that a freely falling body has some uniform acceleration. Similarly, a cycle running down the slope, when a cycle is running down the slope, that means suppose there is a slope like this, and the cyclist is passing through this slope. As the cycle is moving down the slope, the speed gradually increases. Hence here also the cycle running down the slope is also example for having uniform acceleration. Similarly, in third case, ball rolling down the inclined plane. Suppose this is the inclined plane and the body is rolling down, so it is also having uniform acceleration as its speed gradually increases from top to bottom of the inclined plane. So these are some examples for uniform acceleration.